So in this video, we're going to go over how to graph lines if they are in slope-intercept form, and we'll also talk about parallel and perpendicular lines. So slope-intercept form, what does that look like? So y equals mx plus b. So when we say we want the line in slope-intercept form, this is what we mean. The y's all by itself on one side of the equal sign, and then you have, right, the x coefficient, x plus or minus, and then a constant term. So m is the slope. So slope, right, the rise over run for your line, and b is the y-intercept. So m, the slope, it's always the x coefficient when you have put your equation in this form, when you've solved for y. And b, it's the constant term. It's going to be the number that's right by itself. It doesn't have a variable associated with it. And then the x and the y, those are all of the ordered pairs that live on the line. Okay? So we're going to practice. I have 3 lines written here, and we're just going to find the slope and the y-intercept for each. So this first one, y, so they're all solved for y already, so we don't have to do that part. So y equals 2x plus 7. Right, so the slope, and you can either write the word slope or you can just say m, it doesn't matter. So the slope is, right, the x coefficient. So the slope is 2. And the y-intercept, which I'm probably just going to do y hyphen int, is the number 7. Now, I'm going to take a little pause here because usually I'm not going to write it like this. Maybe I'll write b equals 7. But an intercept, remember, is an actual point on the line. It's on the graph. And so points are ordered pairs. So I would probably write my y-intercept as 0, 7 so that it looks like the point. Okay, so I'm going kind of up in order of difficulty. So this next one, y equals x over 3 minus 4. So what is the slope this time? What's the coefficient of the x? So coefficient, right, what is multiplying it? So if you had to write that x over 3 as x times something, what would you be multiplying it by, right? So I'll write it up here. X over 3 is the same thing as 1/3 times x. Okay? If you're having trouble seeing that, go ahead and stick a 1 under the x. Remember, you can put 1s under things and it doesn't change it. So then if you multiply across, that'll get you that x, and 3 times 1 is the 3. Okay, so my slope is going to be that 1/3, and the y-intercept 0, -4. Right, the sign comes with the y-intercept. Okay, last one. Y equals -x. Kind of seems like it's missing something. So what are you allowed to do when something's not there? Okay, so the slope. What's the coefficient in -x? What's the number multiplying the letter x? Yep, exactly, -1. And the y-intercept, well, there isn't anything there. So when there's nothing there, that means it is 0. So it's going through the origin. Okay, so now what happens if our lines are not automatically solved for y? Well, first off, how do we know the graphs are still lines? And I'll tell you, the way we know is that y is raised to the first power and x is raised to the first power. So neither variable, the x or the y, has an exponent written. That means it's understood to be 1. Okay, so in both of those, note there's no x squared, there's no y squared, there's no square roots. That's what makes them lines. So x and y are both raised to the first power. Okay, so then to identify the slope and the y-intercept, you have to put it in the slope-intercept form, which means we need to solve for y. So solve for y. Okay, so here we go. We're going to practice writing these in slope-intercept form and then find the slope and find the y-intercept. So my first one, 3x equals y plus 1. Right, so there's the y. It does not have to be on the left-hand side. I just need the y all by itself. So no coefficients, nobody else adding or subtracting it. I just need to isolate the y. So I'm going to leave it where it is because right now it's a positive y, which is good. So that means this positive 1 has got to go. So just like solving equations in one variable, we're going to subtract 1 from both sides. Right? Doing the same thing to both sides gives me an equivalent equation. So now I have y by itself on the right side. That's fine. And then on the left, I have 3x minus 1. So with an equation, you can swap them if you want to, so that I could also write that as y equals 3x minus 1. Okay, same thing. So now once it looks like this, we can say that m is and b is. M is, right, the x coefficient, so 3, and b, 0, negative 1. Good. Okay, how about this one? Do we still have a line? That's a lot of stuff there. Is it still going to be a line? Well, let's see. Here's my x, exponents 1. Here's my y, exponents 1. I think we're good. So we're going to go ahead and distribute. We have to solve for y, so we have to see what all this stuff is. So I'm going to get a negative 4x minus 12 minus 2y plus 2 equals 5. Huh. Okay, well, that's a lot of stuff. I see some terms I can combine here on the left side, so let's go ahead and do that. So negative 4x minus 10 minus 2y equals 5. Okay, so I only have one x term and one y term, right? So that's pretty good. Now I want to have y equals. I really do not like dividing by negative signs, so I'm kind of thinking a couple of steps ahead. So here's the y that I need to solve for. So I need to get rid of the 2 and the negative 2, and I need the y to be by itself. So there are, a couple of ways I can do it. What I'm going to do is I'm going to add 2y to both sides. So it's legal, right? Because I'm doing it to both sides of the equation. And then in my next step, I'm going to subtract the 5 over. Okay, so that's going to get me where I need to be. So I have the negative 4x, I have the minus 10. These guys just added. I'm to the equal sign, and I have 5 plus 2y. Okay, so now the 5's got to go. So we'll subtract 5. Right, it's a term. To move terms, we subtract or add. 2y equals, right, these guys added away. I have negative 4x still, and that looks like minus 15. And then my last step, I'm going to, divide by 2. So I divide the y by 2, and on the left side, I divide the whole side by 2. Okay, so everybody gets divided. Didn't leave myself quite enough room. Where can I? Let's see, I guess I'm going to have to scrunch down here. So now I've got y equals, so when I divide and I have 2 terms in the top and the 1 term in the denominator, I can split that apart. So I'm going to have negative 4x over 2 minus 15 over 2. Okay. Y equals negative 2x minus 15 halves. Okay, and I did not leave myself nearly enough room. Let's see if so my slope, I'll just circle it because I don't have any room, is m, right? Negative 2 is my slope, m. And then negative 15 halves is the b, right? Because we got the y all by itself. Okay, let's see. I'll try to space better on this next one. So solving for y. Again, just because I don't like the negative coefficients, I would add 2y to both sides, and then subtract 12 from both sides. So 6x equals 12 plus 2y, and then take away the 12 from both sides. 2y equals 6x minus 12. Now we divide both sides by 2. Y equals, and again, right, it gets split apart into the 2 fractions, each with 2 in the bottom. So that y equals 6 over 2, that's a 3x, and then 12 over 2 for minus 6. So I'm going to go ahead and here's the equation of the line in slope-intercept form. Y equals mx plus b, and m is 3, right, the x coefficient, and b 0, negative 6. Okay, here we go. Now, if you're given information and you need to come up with the equation of the line, right, what you're going to do is you're going to either, well, you're going to plug the values in for m and b and then leave the x and y in the equation, right, because they have to stand there for all of the points that are on the line. So let's write the equation of a line that has a slope of 1/5 and a y-intercept of 0, 3. Okay, so y equals mx plus b. So 1/5 goes in for the m. So 1/5 times x. And then plus b, right, we just do the y part. So we're just going to do plus 3. And that's all. You can write that 1/5 x as x over 5, or you can just leave it 1/5 times x. Doesn't matter. All right, so let's go ahead and practice graphing. So when you graph a line, many people find it easier to use the slope-intercept form. So if we're going to draw our line that way, what we're going to do is we're going to start at the y-intercept, we're going to find that point, and then we're going to count off the slope to come up with the next point. So here's our first one. Y equals 1/3 x minus 4. So we're going to start at the negative 4. So it's the y-intercept, so we go on the y-axis to negative 4. There's that point, 0, negative 4. And when I say count off the slope, remember slope is rise over run. So 1/3 is our slope, and that's rise over run. So we're going to rise 1 and then run 3. So up 1 and then to the right 3. And let's do that one more time. Up 1, right 3. Now you can also go down and left. Can you see that that's going to get to the same point? So down 1 and then left 3. 1, 2, 3. So I just went and grabbed an envelope so I could have a straight edge. Let's connect those points. Okay. Oops, sorry. So there is a graph that represents all of the points that are on that line, right? And some of them we actually, right, we had 0, negative 4, so it looks like 3, negative 3 is on there, and 6, negative 2 is on there, right? There's the one when we went down and left. So negative 3, negative 5, and you could check and make sure that all of those values make this equation true. Now, just so that you know, all of those other points that we can't read off nicely because they don't land on one of the, the cross marks, those are also valid points, and they would make it true if we knew what they were. Okay, so let's do this next one. Y equals negative 2x plus 1. So remember where you're going to start. Right? 0, 1. Y-intercept, and then we're going to count off the slope. So the slope, negative 2. So when it's an integer, right, a lot of people like to stick a 1 on the bottom so that we know how far to run. So then we're going to rise over run. So we're going to rise, but we're rising negative 2. So we're going to go down 2 and then right 1. So when your slope is negative, you need to make sure that, right, you have a negative slope on your line. So it needs to be falling as you come to the right. So if it's negative, either the rise is negative or the run is negative. But don't do them both negative, because then you have negative divided by negative, and that's a positive, and then you're going to get the wrong line. Okay, so negative 2 over 1, down 2 over 1. I'm just doing a couple more. Down 2 over 1. So think about how we could have gone up instead of down, what that would have looked like. Okay. I could have gone up 2 and then left 1, up 2, left 1, right? And it's the same slope, right? I just put the negative sign on the other value. Okay, parallel and perpendicular. So two lines are parallel if, right, they never intersect and their slopes are the same. So parallel lines have exactly the same slope. The symbol we use for parallel, it looks like the double L's in parallel. So just two lines right next to each other. Two lines are perpendicular if, not is, if they intersect at 90 degrees, right? They make a right angle when they come together. And their slopes are opposite reciprocals of each other. So the symbol for perpendicular is an upside down capital T. It kind of looks like a road sign, right, when you come up to a T intersection. Now, opposite, we mean opposite sign. And reciprocal, remember, we flip. Now, opposite reciprocal, I usually am not going to say that unless I have to. So what I'm going to be saying is we're going to flip and change the sign. Okay, so here we go. Determine if the lines below are parallel or perpendicular or neither, right? Most sets of lines are going to be neither, except when we're practicing. So, first one, A, is kind of nice because it's already solved for y. So y equals 2x minus 8, so that slope. So we'll call that L1. That's okay. And this one here will be L2. So the slope for L1 is 2. And the slope for L2 is, the slope for line 2 is negative 2. Okay, so if we look at 2 and negative 2, are they exactly the same? Nope, so they're not parallel. And are they opposite? Yes. Are they reciprocals? No. So this one here, this pair, is a neither. They're neither, right, parallel or perpendicular. Okay, how about this next one? So again, they're also solved for y, which is nice. So L1 and L2. So the slope of L1, okay, we practiced this already, right? It's 1/3. And the slope of L2, negative 3. Okay, so are they parallel? Are they exactly the same? No. Are they perpendicular? Are they opposite? Yes, they have the opposite signs. And are they reciprocals? Yes, they are. So these two lines are perpendicular. And finally, before we can do C, we have to solve for Y. So let's go ahead and do that. So we'll do, now I'll go ahead and, if you want to pause and do it by yourself, I'm going to kind of do it in my head if that's okay, and I'll meet you at the bottom. So Y equals negative 1/2 x plus 7/4. And for the second line, Y equals negative 1/2 x. So L1, L2, so the slope of L1 is, my L1 keeps looking like a 4, sorry about that, is 1/2. I'm sorry, negative 1/2, you're right, negative 1/2. And the slope for line 2 is also negative 1/2. So since those two are the same, we'd say that those two lines are parallel.